Welcome to myprojectbazaar.com. Now we are going to discuss about title of our project, real-time Superpixel segmentation by DBSCAN clustering algorithm. Now we are going to discuss about abstract of our project. In this process, we propose a real-time images superpixel segmentation method with the 50 frames by using the density-based spatial clustering applications with the noise. The DBSCAN algorithm. In order to reducing the computational cost of the Superpixel algorithm, we adopt a first two-step framework. In this first clustering stage, the DBSCAN algorithm with the color similarity and the geometrical restriction is used to rapidly cluster the pixels, and then small clusters are merged into a superpixel by their neighborhood through the distance methods defined by the color and spatial feature in the second merging stage. The robust and the simple distance function is defined for obtaining the better superpixel in these two steps. The experimental results demonstrated that our real-time superpixel algorithm by the DBSCAN clustering output performance the state-of-art superpixel segmentation method in terms of the both accuracy and the efficiency. Now we are going to discuss about the flow diagram of our project. First one is an image acquisition. Here we get one input image. The first stage of any vision system is the image acquisition stage. Image acquisition is the digitalization and storage of an image. First, capturing the input image from the source file by using UI get file and IMRead function. User can able to changing the size of the image by providing the pixel height and width with the help of the IMResize function. Here, image resize is applied means then we go for a Gaussian filter pre-processing method. The input images were linear filtering. We are applying the Gaussian filter to our input image. The Gaussian filter is often used to removing the noises from the images. Its process is employed to filtering the images in order to removing the unwanted pixels in the images. Next, the output value goes to the median filter. The median filter is normally used to reducing the noises in an image somewhat like that of a mean filter. However, it often does a better job than the mean filter of preserving the useful detail in the image. Like the mean filter, the median filter considering each pixels in the images in turns and look at the nearby neighbors to decide whether or not it is repetitive of its surrounds. Instead of simply replacing the pixels values with the means of neighboring pixel values, it replacing with the median of those values. The median is calculated by first sorting all the pixels values from the surrounding neighborhood into the numerical order and then replacing the pixel being considered with the middle pixel values. Next one is the median values go to the superpixel, SLIC superpixel. The superpixel are becoming increasingly popular for users in computer vision applications. However, there are few algorithms that output designing a number of regular compact superpixels with a low computational overhead. We introducing a novel algorithm called SLIC, that is simple linear iterative clustering, that clustering pixel in the combination of 5-dimensional colors and image plane space to effectively generating the compact nearby the uniform superpixels. The superpixel segmentation can be considered as a cluster problem where each superpixel containing a unique features in the color and shape. Next, we apply for a DBSCAN clustering algorithm. In the DBSCAN algorithm is based on the distance based neighbor finding, then labeling the image, then drawing the boundary region based on the distance. The DBSCAN is a density-based cluster algorithm, and it will be improving the performance of the segmentation algorithm by adding the geometric constraints. The proposed method including the two stages, clustering stages and merging stages. First, we aggregated the pixel to get the initial superpixels by DBSCAN algorithm. Secondly, those initial superpixels are refined to obtaining the final superpixel results through the merging the very small superpixel. Here we are applying the different types of threshold values. First one is a distance based threshold applied 1, then 5, finally applied then be comparing with an DBSC clustering algorithm. Now we are going to discuss about the output of our project. First, open the MATLAB tool. MATLAB R 2013 is our tool name. Then open the current folder, select the main.m file and right click the file to run a project. Click run button. Now we are going to select one database image. Now I selected a 2.jpg file. Now run the project. First stage is in our project is get an input image, then resizing the image. The resized images goes to the filtering process. First one is a Gaussian filters. The Gaussian filter is used to removing the unwanted pixels in the images. Next one is a median filter. The median filter is used to removing the repeating pixels in the images. Next one is an first one is an input image. The input images is resized here, then displayed here. The input images is applied for a Gaussian filters to remove the unwanted noises in our images. Next one is a median filter. The median filter is applied to removing the repeating pixels in the images. That is unwanted noises. Next one is a superpixel images. The superpixel is applied here. Next one is a DBSCAN image. The DBSCAN images is applied based on the distance based clustering is done. Then the distance threshold value is 1. Next one is a distance threshold value is 5. Here the DBSCAN image distance threshold value is 5. Next one is we are going to apply for a distance threshold value is 10. Finally we comparing the DBSCAN images. So distance value is 1 and 5 and 10. Thank you for listening. Our demo is completed. Thank you.